Welcome to this lesson video. Today we'll be looking at limiting reactant or limiting reagent. Let us start. In chemistry we use equations to represent chemical reactions. Like for example, let's say we have a substance A, we are reacting that substance with substance B to produce C plus D. Unlike in mathematics, instead of equal sign we use an arrow. Now we have reactants and products. Reactants are these substances before the arrow, and then these ones we call them products. For today's lesson we are going to focus mainly on this because we are talking about limiting reactant. So limiting reactants A and B. Between A and B, one of these are limiting reactant. What is a limiting reactant? Is a substance that is used up completely during a chemical reaction. So one of the two will react and be used up completely in this chemical reaction. The moment that substance is used up, the chemical reaction stops. So today's lesson we are going to determine which substance between the two or three substances will react completely and stops the chemical reaction. Let us look at the first example. We have this chemical reaction. We are reacting hydrogen and oxygen to produce water. Now let us start. We need to determine the limiting reagent. Remember, the limiting reagent is between hydrogen and oxygen. One of the two is the limiting reagent. Now you are given the mass in grams of hydrogen. You are given the mass in grams of oxygen. Hydrogen is 3 grams. Oxygen is 2 grams. Now before we start determining the limiting reagent, what we need to do, we need to find the number of moles for both reactants, and then from there we need to determine the amount of number of moles that is going to react with the other substance. We are going to calculate for both of them, and then the last step we conclude which one is the limiting reagent. So what we need to do now, we need to calculate the number of moles. I will simply tabulate. So we are dealing with hydrogen this side, and then this side is oxygen. So number of moles, it's M over M. There is a lesson video on how to calculate the number of moles. From there it's N, the mass in grams is 3, divided by the molar mass of hydrogen, it's 1. Then in this case we have 2 atoms of hydrogen. Then the same goes to oxygen, we have 2 divided by 2. The molar mass, it's 16. And then we have 3 over 2 mole. Then here we have 0.0625 mole. In most cases I advise you to round off to 3 decimal places. This is the same as 1.5 mole. Just make sure you round off to 3 decimal places. So as you can see here, this is the number of moles we have. This is what we have. Now we need to continue to calculate. We check. It's either we can start with hydrogen or oxygen. Now we start with hydrogen. We are going to use what is called molar ratio. And hydrogen, number of moles of hydrogen divide by number of moles of oxygen. It's equals to, now this fraction, the numerator, I always advise that you put the one you're looking for on the numerator level over the one that you have. In this case, you want to check whether hydrogen is the limiting reagent or what. So we put it on the numerator over the other reactant, which is oxygen, on the denominator. And then from there, we look at the balanced equation. In order for us to determine the limiting reagent, we need a balanced equation. We look at the coefficient. Now you can see the coefficient of hydrogen is 2, then the coefficient of oxygen is 1. So you can see on the numerator level, we said we have this, denominator we have this, equals to. On the right hand side, we put those coefficient. Coefficient of hydrogen is 2, coefficient of oxygen is 1. And then from there, N hydrogen over the number of moles of the one we calculated initially, which is this one. So you substitute by this, the number of moles of which we have of the other substance equals to 2 over 1. And then from here, we can solve for this. We multiply by the number causing the fraction both sides. Over 1. So you multiply both sides by the number causing the fraction. In this case, it's this one. You want to get rid of that. So it's 0,0625, 0,0625. So this will result into 1. Then we are left with N hydrogen. It's equals to, let me quickly punch this. We have 0.125 mole. After this second calculation of number of moles, we can conclude which one is the limiting reagent. Now this is what is happening. Let us compare this and this. Which number is greater than the other? Now initially we have this, and then we only need this to react completely with this. I don't know if it makes sense. After calculating the first number of moles and the second one, you compare the two, which one is greater than the other. Now you can see the second one, it's smaller than the first one. So it means we need this number of moles to react completely. Actually, we need this number of moles to consume this reactant completely. And then do we have this number of moles? We have more than that. We have 1.5. 1.5 is greater than 0.125. So we only need 0.125 for this reaction to stop, of which we have more than that, which is 1.5. So we can conclude that hydrogen is not the limiting reagent. In fact, we have more than what is required for the reaction to stop. And remember, the reactant which makes the reaction to stop is the limiting reagent. Now we can go ahead and prove by calculating how many number of moles is needed to stop the reaction. So in this case, we are using oxygen. We are trying to calculate oxygen. So the numerator, we put oxygen, number of moles of hydrogen. It's equals to 1 over 2. From there, we have O2 over 1.5. It's equals to 1 over 2. And then we have O2 over 1.5. It's equals to 1 over 2. So you multiply both sides by the number causing the fraction, which is 1.5. 1.5 this side. Then this will result into 1. And then we have N is equals to, no, it's NO2, number of moles of oxygen is equals to. And then this will be 0.75 mole. Now we need to compare. Now look at this. Initially we have 0.0625 and then we need 0.75. We don't have this much of number of moles, so it means this is our limiting reagent. Oxygen is our limiting reagent, and then this one will be our excess reagent. I hope you can see this. You simply compare the first number of moles and the second one. If the second number of moles is greater than the first one, it means that is the limiting reagent. We can come up with a sort of an equation. Remember the first number of moles and the second number of moles. Okay, so we say if the first number of moles is greater than the second number of moles, so we are talking about these numbers. If this number is greater than the other one, or the other one is greater than this one, then it means this one is the excess reagent. Then if you calculate, you find that the first number of moles is less than the second number of moles, then you conclude that this is the limiting reagent. Let us look at more examples and see if you can understand this. We look at the second example. This one, we have hydrogen reacting with nitrogen to produce ammonia. We have 4 grams and 2.8 grams. As you can see, this chemical reaction is balanced, so we are good to go. So we are dealing with hydrogen this side, we are dealing with nitrogen this side. So we are calculating the number of moles. The mass is 4 grams, and then we have 2 atoms, 1. The mass is 2.8 grams, and then we have 2 atoms, and it's 14. We have 2 moles. This is what we have currently, and then for this one we have 0.1 mole. This is what we actually have. Then we need to continue to calculate the second number of moles and determine or conclude which one is the limiting reagent. So from here we start with hydrogen, so we have H2 divided by N and 2, it's equals to, we look at the coefficient is 3:1. So we have 3 over 1. From here we have, it's 0.1, 3 over 1. And then when we multiply both sides by 0.1, this will result into 1. So we have NH2, it's equals to 0.3 mole. From here you can compare which one is the limiting reagent, which one is greater than the other one. As you can see, we have 2, and then we only need 0.3. So you can see that we already know that this is the excess reactant. We have more than 0.3. We need 0.3, but we have 2 moles. We can go ahead and calculate this one. So we have number of moles of nitrogen over number of moles of hydrogen is equals to 1 over 3. We have, it's actually nitrogen, not, yeah, nitrogen, hydrogen, no, I repeat the step, it's 2 and then equals to 1 over 3. Multiply both sides by 2, this will result into 1. We have this, which is 2 over 3. This is 0.667 mole. So we need 0.667 mole of nitrogen. So let us check whether do we have enough of that. You can see that this one is smaller than this one. We need 0.667, but we only have 1.2. So we can conclude that nitrogen is the limiting reagent. Our next example, you can pause the video, try to determine the limiting reagent and play the video to verify your answer. So we tabulate. We have aluminium this side, we have iron this side. It's actually not iron, it's fluorine. It's fluorine. So this 2 must be here. Then from here we have number of moles. We have 10 grams divided by aluminum is 27. We only have one atom. We have 18 divided by 2 multiplied by 19. 0.370 mole. Then for the second one we have 0.474 mole. So these are the first number of moles we need to calculate. Continue. So N aluminium divided by number of moles of fluorine, it's equals to 2/3 0.474, it's equal to 2/3. Multiplying both sides, we know that we will end up having this 2/3, 0.474. Aluminium is equals to 0.316 mole. This is the second number of moles. We need to continue. Before comparison, let us quickly do this one. We have fluorine, number of moles of aluminium, it's equals to 3/2. Fluorine, we have 0.37, 0, it's equals to 3/2. Then from there, multiplying both sides by the number causing the fraction, we have this. From here, we simply punch this on our machine. We are going to have 0.555 mole. We compare now. Which one is the limiting reagent? We look at this one. As you can see, 0.474 is what we have. We need 0.555. We don't have 0.555, so this is the limiting reagent. Looking at the other one, we can see that we have 0.370. We need 0.316, which we have enough. So this is our access reagent. That's it for this lesson video. This is Bahula SJ. Thank you very much.